Mute.
अरे कल फ्रेंड ने कहा
Devjit Babu, please make me co-host. Devjit Babu, am I audible? हेलो। Good morning, everyone, and good morning, Dr. Amrutangsu Panigrai, sir. Sir, am I audible?
Yes, sir. Audible, sir. Audible.
Okay, sir. Thank you. So, sir, can I start the session?
Yes, sir.
Okay. So, today's host, Dr. Amrutangsu Panigrai, sir. Dr. Amrutangsu Panigrai is an accomplished academic and researcher currently serving as an assistant professor in the Department of Computer Science and Engineering at Shiksha Anusandhan, Bhubaneswar, Odisha. He received his Bachelor of Technology BTech degree in Computer Science and Engineering from Biju Patnaik University of Technology, which is in Odisha, in 2011, followed by a Master of Technology, which is MTech in Information Technology from the College of Engineering and Technology, presently known as OUTR, Government of Odisha, in 2014. He completed his PhD in Computer Science and Engineering from Shiksha Anusandhan University in 2023. Demonstrating a strong commitment to international research collaboration, Dr. Panigda is currently undertaking postdoctoral research at Lincoln University College, Malaysia, where he continues to expand his work in next generation intelligence systems. His core research interests lie at the intersection of blockchain technology, machine learning, and deep learning, with a focus on their application in areas such as secure data sharing, intelligent decision making, and trustworthy computing system. Dr. Panigda is having more than 10 years of teaching experience in the graduate and postgraduate level in various
இன்னைக்கு
AICT
78 தான் இருக்காங்க.
approved institution. Dr. Panigrai has published more than 60 research articles in reputable SCIE Scopus Index journals and international conferences.
சரி, இன்னைக்கு நல்லா படிச்சு நோட்ஸ் எல்லாம் எடுத்து சாயங்காலம் 4 மணிக்கு.
In recognition of his expertise, Dr. Panigrai serves as a reviewer for several high-impact journal index in SCI and Scopus, contributing to the academic community through peer review and critical evaluation of emerging research. He is also an editorial board member of BMC Artificial Intelligence and the Edelweiss Applied Science and Technology Journal, which is Scopus Index. And today's his title of talk is Cognitive Foundation and Future Frontier of Blockchain, a layered pedagogical approach from concept to research. So thank you, Mr. Panigrai, Dr. Panigrai, sir. Sir, over to you, sir.
Okay. Thank you, sir. Thank you. A brief introduction, sir. So, can we start presentation?
Okay, you can start.
Sir, I'm going to share my screen.
Oh, thank you, sir.
Is it visible, sir? Hello.
Yes, sir. Your screen is visible.
It is visible. Okay, sir. Thank you.
So, এই এখান থেকে pin নাও, pin। নোটটা খুলো।
Good morning to all of you, Department of ECE and the respected faculty members who are there. Today, I will be discussing about the cognitive foundations and future frontiers of blockchain, a layered pedagogical approach for concept to research. Myself, Dr. Amrutangsu Panigrai. I'm Assistant Professor, Department of Computer Science and Engineering, Shiksha Anusandhan University, Bhubaneswar, Odisha. So these are the contents on which we are going to discuss during the entire presentation. First introduction, then we'll be discussing about the key components of blockchain technology, then the pillars of blockchain technology, then working of blockchain, blockchain application domain means where the blockchain can be applied, then blockchain platform, double spending attack, consensus mechanism, blockchain-based tools, security via blockchain. That means whenever the blockchain has been developed, initially it was developed for something else, but now on what basically the blockchain is being implemented for the security purpose. Highest priority has been given for the blockchain towards the security purpose. Then three different use cases where the blockchain we have implemented, then the different resource opportunities we have for the blockchains, then conclusion. First of all, we have to discuss how the blockchain has been introduced into the world. Initially, into the 1982, the Byzantine general problem is a very good game theory problem in where the Byzantine having some force, means army. I'm talking about the army force. So those army force are divided into different battalions, right? There's a so one day what Byzantine thought that one fort they will be capturing, and from the four different directions, east, west, north, south, they will be attacking simultaneously. For that, what they make the plan is they have divided the entire battalion into four different groups. Each battalion will be heading towards each and every direction. That means one battalion will be moving towards or attacking from the east, another is from west, another from the south, another from the north. So the each battalion or each group will be headed by a general. That general is called as Byzantine general. But what their strategy is, their strategy is they will send. Suppose simultaneously they want to initiate the attack. So what they will do is, simultaneously they have to select one messenger. The messenger will run from east to west, west to south, south to north, and accordingly it will give the message that now we have to start. But the problem is, the probable that the enemy they are going to attack, they can sabotage their plan by intercepting the messenger. In that case, what happens? Suppose the general has given the message, okay, now we have to start the attack. So in that case, the messenger is being interrupted. That means it has been malicious by the enemy. So what they have done, they have changed the message. So the message is like, now we cannot attack, right? The message, wrong message has been delivered. So one group is attacking, second group is receiving the message, so we cannot attack right now. So the method is happening like they cannot attack simultaneously. So this is the Byzantine problem which is being developed to understand why the blockchain technology is being invented. Okay, what is the importance of blockchain? This is the scenario why the blockchain has been implemented. So this is the well acquainted diagram or figure where we are facing or we are using in our day-to-day life. That means we want to go to the bank for withdrawing the money, for depositing something, for any kind of transfer, anything we go to we have to, suppose I have an account in SBI. So I want to transfer, I want to deposit, I want to withdraw anything, I need to really depend on the bank server, SBI server. But question is, what if that server goes malicious? These are the two scenarios based on which in 2009, Satoshi Nakamoto, it is a not actual name, it is a synonym, it is a pseudonym, you can say. So this pseudonym has invented this blockchain technology in terms of Bitcoin concept. What he is telling now in this case, we are depending on the bank server for any kind of activity, like we want to pay, we want to deposit, we want to withdraw. For anything, we have to deposit or we have to depend on the bank server, right? So in this case, what happens? The blockchain or the Satoshi Nakamoto has invented that no, we don't have to depend on a single server. Instead, what we'll be doing it, let us convert this network into a peer-to-peer network. What is a peer-to-peer network? Peer-to-peer network means every node will be connected with each other, right? So direct communication will be done. Suppose I want to transfer I want to transfer some money to the second author or second user. So I did not to depend on any bank server and a centralized server. So this bank server we are utilizing right now is called as your centralized server. So if centralized server goes malicious, the entire transaction, entire user's data, entire money will be in danger. So that's why the 2009 the Bitcoin has been developed with in mind that we have to convert this network into a peer-to-peer network where the decentralization will be there. What is decentralization? Here we are depending on the bank server for any kind of activity. So there in the Bitcoin concept, we don't have any bank server. We don't require any centralized server. So we are having 5 nodes. That means 5 nodes are behaving like they are the servers for the network. Okay, so this is the main objective why the blockchain has been introduced. The blockchain has been introduced to avoid first the Byzantine problem, that is there to understand what is the importance of blockchain. Right. So in the previous case, in the Byzantine, also the same problem is the centralized authority. That means the Byzantine general is the centralized authority. Byzantine general is selecting one messenger who will deliver the message, and now he is giving the authority to the messenger to deliver the message from one general to another general. So if the messenger goes malicious, then the entire process goes malicious. So if we're looking into these two concepts, centralized concept, the blockchain has been taken into the picture. So now we have to understand what is blockchain. So basically, blockchain is a decentralized concept acting on a peer-to-peer network. What is peer-to-peer network? As I've already explained, the peer-to-peer network is something where all those networks, all the nodes will be connected to each and every participant. There will be one-to-one communication in between each and every node. So another key point is blockchain has a ledger. That ledger is called as ledger. You can say that ledger is just like a record where every transaction going inside the network needs to be mentioned. So this netted or this ledger or this record has been decentralized. Is it decentralized in nature? That means no one is holding the responsibility to maintain that ledger. Right. So each and every network participants has to believe that we have to maintain our own DLT. Right. Writing a DLT is easy, but removing the DLT is not possible. Removing something or modifying something from the DLT is not possible. Okay. So that's why the blockchain is using the DLT, distributed ledger. Later on, whenever we move towards, we will be understanding what is DLT, actually distributed ledger technology. For right now, we can understand that ledger is nothing but a record which needs to be maintained by the all participating networks. Okay. Talking about the blockchain evolution. So initially in 2009, the blockchain 1.0 has been developed in terms of cryptocurrency, that is called as Bitcoin. Then to the blockchain 2.0, blockchain 2.0 is nothing but the smart contract. Talking about the blockchain, it is purely automated system, right? Automated system means if something is happening, this should happen, right? This should trigger out. So this is called as automation. So blockchain 2.0 is giving the idea of smart contracts. Smart contract is something which is it is a piece of code which will be stored in the blockchain network with a predefined condition. Right? If this condition arises, automatically the smart contract will be invoked and certain output will be given to you. Next is blockchain 3.0. Blockchain 3.0 is the DApps. DApp stands for decentralized application. Decentralized application is where no central authority will be there. Each and every participating in the node will be acting as a certificate authority. What is certificate authority? Certificate authority is holding the responsibility for validating the transaction inside the network. That means you can say that certificate authority right now, it is now equivalent to a bank server. But the bank server is constant in the previous case. But here the certificate authority is not constant. For every transaction, the certificate authority will be changed. How they will be changed? Some election mechanism will be applied so that each and every node can be act as your certificate authority for the network. So next is blockchain 4.0. Currently, we are running in blockchain 3.0 and 4.0. Blockchain 4.0 has been specifically developed for the industry purpose. That means suppose we want to apply some green blockchain based systems, then we have to apply the blockchain 4.0 sustainability goal. So that is also blockchain 4.0. If you are dealing something that is related to the industry, you have to go for the blockchain 4.0. But you have to remember that without blockchain 3.0 and 2.0, blockchain 4.0 cannot be produced, because combining blockchain 2.0 and blockchain 3.0 will be resultant is blockchain 4.0. Okay. So considering about the blockchain, the first term is coming in the mind is what is block? Block is nothing but a combination of transactions. So initially, suppose we have established a network, we don't have the blockchain. What is blockchain? Blockchain means it will just break down the words. It will be chain of blocks, right? Chain of block means each and every blocks will be connected with each other in some manner. What is the manner? I will be explaining. So first block, whenever you don't have any transaction in the network, first block is not having the previous block. So first block is called as Genesis blocks. Genesis block means the block which don't have a previous block. The first block is nothing but called as is Genesis block. Each block will contain two things. One is timestamp, when the block has been started. Another is Merkle root tree. Merkle root tree, it is the combination of different transactions. Merkle root tree is the hash. Actually, in Merkle root tree, the hashing mechanism will be used. Hashing mechanism used means each and every header or every key of every block will be hashed by using some hashing value, and they will be stored in a tree-like structure. That is called as Merkle root tree. So next is transaction. In transaction, what we're doing? User ID, key, data, and operation. What operation we want to do? Data. What data we are having? Key. Key means each and every block or every node, whenever they want to transact in the network, in a blockchain network, they are having two keys. One is private key, another one is public key, right? As usual in the cryptographic concept. Because here also we are applying the cryptographic concept. For hashing, we are applying in the Merkle root tree, and normal cryptography approach, private key and public key concept we are using in the transaction. Public key will be used for the public key, and private key both will be used for the encryption and decryption. One for the encryption, another for the decryption. Like with the cryptographic hashing or cryptographic theory we are doing. So block of chains means one block will be containing the address of the previous blocks. This is way the blockchain will be there. In case of a blockchain network, different blocks will be connected with each other by the address of the previous block. So this is what the structure of the block in a blockchain. The blockchain contains the header, the timestamp, the Merkle root tree, and your data. So the data is nothing but you want to transact, right? Key, it is the private key and public key pair. Operation, what operation? Whether suppose I will be dealing with money transfer from one end to another end. So here I need to use the transfer. It is a transfer is a function which I need to describe in the smart contract. If the transfer arises, then what I have to do, right? ID, each and every whenever node joins a blockchain network, a unique ID will be generated, and that ID will be unique. That means no other node will be having the same ID. So this is the block overall concept of block and how they are connected with each other. They will be connected with each other by means of the address of the previous block. Remember, the address will be always in a hashing format. No way you can directly store anything in a blockchain. Everything has to be converted into the hashing code. Use the hashing mechanism, then store the result in a block. This is called as your block. Then talking about the different components of blockchain. What are the components? Ledger, distributed ledger technology. Then wallet. Wallet means suppose I will be telling that I have already explained in my past use case. Whenever you are developing a DApp, decentralized application, right, for a supply chain management. So for supply chain management means I have to transfer money. The money may be in Ethereum, or if I will be deploying in this Ethereum platform, so it will be Ether, ETH, right? But in case of if I'm developing in Bitcoin concept, then BTC will be my currency. So I need a wallet. We cannot transfer directly the BTC or the ETS from one end to another. I need a wallet. So the wallet is also a key component. For example, wallet becomes MetaMask. MetaMask is a well-known Ethereum wallet which can be used for transferring the money from one end to another. Okay. So next is system management. System management means what? System management means the storing capacity. That means the off-chain and on-chain storage. Which data needs to be stored at the device end and which data needs to be stored on the blockchain network. The off-chain storage is always high as compared to the on-chain storage because it will be loading on the blockchain network. The performance of the network will be severely down. So we have to ensure that the blockchain network never lies down. That means every time whenever I want to connect with the blockchain network, it will be in active mode. All node needs to be active because if we want to transact, we want to send any information, I need the permission from each and every participating node present in the blockchain. So ensure that each and every node present in the peer-to-peer network are in active mode. Next is peer-to-peer network. What is peer-to-peer network? Already I have explained. What is peer-to-peer network? Peer-to-peer network is something where each and every node will be connected with each other so that one-to-one communication is possible. Second, last is smart contract. Smart contract is something that is a piece of code. It is there to automatically trigger something. That means if I am dealing something, this happens scenario, this will be the resultant. Okay, if I will be applying the transfer function, this money will be transferred from the user ID A to user ID B. So if transfer keyword arises, then we have to do these things. So this is what the working of your smart contract. Then event. Event means what? What kind of operation? Because actually in blockchain, two kinds of operation we are doing. Either we are transaction, we are initiating a transaction, or we are validating a transaction. Right? What kind of event you are doing? If you are a certificate authority, then definitely you are validating a transaction. I do remember that the blockchain concept is nothing but a decentralized theory where no centralized component will be there. But we need to remember as well as we must require a certificate authority who is going to validate a transaction, validate a communication, validate a transaction. For that, I need to select my own CA. Instead of having a centralized CA, I need to select my own CA. Like this is called as event. Then membership means what? Whenever a node wants to become a blockchain, wants to become a participant of a blockchain node, he has to execute a smart contract, right? Suppose I want to enter into a blockchain network, then each and every participant in the network should allow me that I can be a participant. Otherwise, I cannot be the participant. So that is the main advantage of blockchain network. Doing something requires the permission from entire network. So these are the key components of blockchain network. Then talking about the what are the pillars of blockchain technology. Pillars of blockchain technology: decentralization, transparency, and immutability. What is decentralization? Decentralization means in every transaction, the new thing will be happening. No centralized authority will be there. No dependency will be there on a single node. The entire network has the capacity to select their own authority for each transaction. How they will be done? That there is a mechanism how they will be done. The mechanism called as consensus mechanism. Through the consensus mechanism, we can deploy our own. We can have our own CA, our own authority for my turn. Suppose I want to transact, I have the capacity that I can select my own CA, my own authority, who is going to validate my transaction. For that is we have a lots of mechanisms like proof of work, proof of stake, derivative proof of stacks, various mechanisms are there. How we can select? I will be discussing all those things as well. Next is transparency. As we know that the blockchain is having a DLT concept in its mind. So what the DLT, what you are modifying, it is visible to entire network. So nothing is hidden there. So what you are doing, what you are storing, what you are modifying, everything is visible to the entire network, right? So next is immutability. Immutability means once the blockchain has no data has been written to the block, it cannot be modified. Right, so that's why it has been mentioned that it is nearly impossible to modify the data that has been stored in a blockchain block. Okay, so these are the three pillars of blockchain technology. Next is decentralized. This already I have explained. So decentralized, the first figure shows that the centralized concept where every node is depending on one node. Second one is decentralized. Decentralized is nothing but a peer-to-peer network. Here, entire peer-to-peer network is not there. Actually, this is a semi-decentralized network we have represented, where each and every no centralized authority is present. Each and every node can act as your authority for different transactions. Suppose you want to transact some money, then choose your own server. Choose your own server. He or she will validate your transaction, then transact the money from one end to another end. No need to go to the bank. No need to depend on the single server. So you can choose your bank server. Then depending on the server, but you have to trust your server, right? You have to trust your server. If you are choosing something as the authority, you have to trust, because trusting is something, it is very important for the blockchain point of view. Malicious attack is possible, and also there is a preventive measures how we can avoid these attacks in a blockchain network. Next is transparency. This is the just snapshot of our DLT we have implemented. So this is a snapshot. So we have means every data has been stored from what? From user A to user B, from source to destination. What is the value? What is the timestamp? What is the hashing? And what is the block number? Everything has to be mentioned in a DLT. This is what called as your DLT. This is the snapshot of DLT. Okay, so TXS means the transaction hashing. A direct transaction will be not visible, right? Direct transaction is not visible to anybody else. The direct transaction will be visible to the intended recipient. Then is block. In which block we are going to store? Suppose 6 transactions in one block, I can store n number of transactions, right? So one block. What is the block number? What is the S? S means what time before you have just initiated the transaction. Then from source address, destination address, then your value. And last one is the what is the currency you have to pay. Okay. Next is immutability. So this is what called as your block representative. You will zoom into this. This is the hashing mechanism of your block. Right. If you zoom into the block, whenever you are storing the data, this data is being hashed. That data has been encrypted into a different. So the input message is this. The hashing, after hashing, the message is converted to this. Hashing key will be given to the intended recipient. It is not available for the entire public, entire network. It is only available to the network. Once this has been written, in the DLT, it cannot be modified. You cannot change this B to C. Right? You cannot make the 6 to 7. It is not possible because the blockchain says that it is quite impossible to alter the data once it has been stored in the DLT and block. So this is what called as your 3 pillars of your blockchain technology: decentralization, immutability, and transparency. Then consider, now we have to think how the blockchain is working actually. Initially, the sender, suppose you are trying to send some message or money, something you want to send to the receiver, right? I will be considering it as a message, not as a money. I will be considering it as a message. So what happens whenever I will be transferring, I will be initiating the transaction. What I will be doing is I know that I need to select my own CA, or I need to select my own authority. What is the basic mechanism we are having? It is the proof of work. You show your capacity, I will be giving you the authority, right? Capacity means whenever a sender will send a document, before that it will send a puzzle to the network. Like suppose 6 nodes are there, and one node will be initiating the transaction. 5 other nodes are there who will be looking that yes, we can be the CA for the corresponding transaction. Right? So the sender will first initiate a puzzle. The puzzle is not number only once. That is a random number, or random. It will generate a random number which cannot be generated second time. Nonce means number only once used. It is a heavyweight arithmetic operation which will be transferred to the network, and each and every participant network will be utilizing their own resources to solve the puzzle. Right? Suppose I will be giving 2 plus 3 is equals to 1. Who will be bringing the first result? He will become my central authority, or he will be giving my certificate authority. So what happens? All the nodes will be becoming very busy to solve the puzzle. Those are interested, right? Those are interested. Those are not interested, I cannot force them that you solve it and show me the result. So those are interested in becoming my because whenever I want to become a CA, I will be gaining some mining amount. That means I will be gaining some bounties for that. Right? For bounties, I will be bounties in terms of BTC or in terms of ETS, I will be gaining for validating a transaction from the sender side. So that's why without CA, it is not possible to send the message from sender to receiver. So now it is a responsibility of sender to choose its own CA. So what it will do, it will just broadcast the puzzle to the network, that number only once used, and using that puzzle, each and every present node who are interested in becoming as a CA will be trying to solve the puzzle, right? Who will be submitting the result first to the sender? The sender will decide, okay, that person will be becoming my CA for the corresponding transaction, and that person will be responsible for validating the current ongoing transaction, and it will send the message. Then only the message will be sent. how the message will be actually validated. Suppose I will be telling that some student has given the application to the HOD. What the application HOD will be doing, HOD just put the signature at the appropriate place. Then the signature, the application is verified by the HOD. Similarly, in this case, what the document the sender will send, the document will be signed by the certificate authority and digital signature will be sent to the receiver for checking the identity is matching or not. If the identity is mismatching, the document cannot be retrieved. If the identity is matching, then only the document can be retrieved by using the public key. Understood? So that means we requires the signature of the certificate authority. Certificate authority is nothing but the HOD for the transaction. He will be responsible, he or she will be responsible for putting the digital signature on the document. Once the digital signature has been done, the copy of digital signature will be forwarded to the receiver. Then the receiver will check the digital signature for the received document and the digital signature received from the network are matching or not. If they're matching, then only the message will be delivered and message will be decrypted by the receiver. Okay. So this is what we are dealing, or we are talking about the how the blockchain has been. What we have discussed is number only once used, not. So this is the concept of proof of work. Because here in this entire picture, we can say three things. One is block, through which I can send the node data. One is node, who is going to validate my data. And one is data. That means data means transactional data. What I am going to send. Block means where I need to store the data. And node means who is going to validate. So there are three different unique parts present in this diagram. One is node, another is data, another one is your transaction. Sorry, a node, block, and transaction. These are the three different parts, or you can say main components present in working a blockchain. Okay. Next is what can be the different application domain where the blockchain can be used. Blockchain can be used like for business. Business means supply chain management, you can say. For healthcare, for developing any in 4.0 applications. For this, we can have the business. Second one is education. In education means library management system. One is the well-known example of your blockchain technology where there will be no librarian will be present in the network. Each and every participating or each and every student will be connecting with each other. But condition is you cannot borrow the books until entire library doesn't know that yes you are borrowing a book. Next is IoT, and IoT I can say that okay, in IoT I can say smart agriculture system. In that case, we can apply the blockchain. Governance. Governance means voting system. Voting system is a well-known application that is being developed. That is already developed. Few of them, few of the applications are there. They are giving the blockchain in governance, in voting system. Next is security. Security is actually the most implemented area for the blockchain. Security is where we are developing something called as your public key infrastructure, right? PKI. Next is finance. Finance means suppose I will be developing something. For example, finance is something is developed on the Bitcoin concept. That is called as finance. Healthcare is also in healthcare. Also, it is quite equivalent as supply chain management. One use case I will be showing for the healthcare where the blockchain has been implemented for the healthcare. That means the patient data is visible to the doctor and doctor information is visible to the patient very clearly. No hidden information is there. The entire patient history is available on the dash. The doctor who wants to verify him has the access to verify the data as well. So these are the few areas. Beyond this also few areas are there, like NFT is there. Right? So suppose I wear a shirt, right? I wear a shirt and each and every user has his own unique shirt, right? The shirt will be attached to a NFT tag, NFT. So if I will scan the NFT, I can say that yes, this is the owner. So this is currently it is under working actually NFT. Talking about the different blockchain platforms we are having for the deployment. One is public blockchain, another one is private blockchain, another one is consortium blockchain, another one is hybrid blockchain. Public blockchain is it is open to all. right? It can be used by anybody in this world. That is called as public blockchain. Private blockchain. Private blockchain means there will be the centralization concept is actually is in mind. So here public blockchain is full centralized, full decentralization. Private blockchain is moving towards the centralized. Consortium blockchain, it is semi-decentralized and hybrid. It is centralized and decentralized. Both will be there. That means it is a public one, it is a private one. I will be giving some examples of available blockchain platforms. Those are interested in working in blockchain concept, they can implement their work in these platforms. So what's in blockchain? Public blockchain. Public blockchain is open to all. No restriction is there. Anybody can join. Private blockchain, it is controlled by a single authority. That means some IBM platform or Hyperledger platform where the end one node is there who is handling entire. That means the network is looking like decentralized, but the decentralized network is controlled by a centralized authority. Consortium means it is a semi-decentralized type of blockchain. It will be in this, the decentralized network will be controlled by a delegated group. That means a group of organizations will be there who will be controlling the network. Hybrid blockchain will be combination of public blockchain and private blockchain. These are the different four different types of blockchains platforms we are having. Now, advantage, what is permission? Public blockchain is called as permissionless and private blockchain is called permission. So what is advantage of public blockchain? Public blockchain is very independent. That means nothing dependence will be there. Anyone can join and transfer, clear transparency will be there and trust will be there, right? But private blockchain, access control will be given to only one organization. Consortium, access control will be given to a group of organizations. Hybrid, access control will be given decentralized as well as centralized. Disadvantage, whenever we are dealing with the public blockchain platform, we are definitely anybody, if the network size increases, the performance will be definitely hampered, right? So for implementing a blockchain, it is very costly to dealing with the public blockchain. Scalability is a real time issue whenever we are dealing with the public chain, because in suppose we will be considering the Ethereum, right? For Ethereum, we can implement the Ethereum by the Ganes platform. We are having the 100 number of node capacity. That means beyond 100 we cannot do, right? So next, security is another limitation present in the public platform. That's why we are developing the public key infrastructure for the public platforms, right? Okay. So trust and audibility are the issues for the private beginners of blockchain. Trust means what? Again, we can say that for the private blockchain, if you will go to the definition, back definition, private blockchain is nothing but where the entire network is controlled by the single authority. So I have to believe on the single authority that okay, he is right and he is handling the network quite effectively, right? But consortium, there will be two issues: security issues, because it is the hybrid blockchain, it is the combination of these two. So the scalability issue will be there, the performance issue will be there, security issue will be there, as well as the trust issue will be there for the hybrid blockchain. Consortium blockchain, it is a semi-decentralized, so access control is a definite layer. So second one is transparency. In consortium, as it is semi-decentralized, the full transparency is not present. Okay, so use cases for the public case, we can use the document validation, as we are already discussing how the document validation has been done in a blockchain network, and cryptocurrency. These are two implementation of public blockchain. Private blockchain, supply chain management can also be implemented by the public blockchain, right? So if you want to very specific, then go for the private blockchain. If you want to commercialize this, that means anybody can use, then go for the public blockchain. Supply chain can also be used for the public and private. Hybrid, it is medical records, right? And real estate. Real estate is money laundering system, right? A land verification system. So this system as or we can say that stock market prediction, right? For that also we can use the blockchain concept. Next is consortium blockchain. In consortium, the application is banking and supply chain. So these are the advantages, disadvantages, and uses of blockchain platforms. So these are the available blockchain platforms, well-known available blockchain platforms for the use. Ethereum, Hyperledger, IBM blockchain, Open Chain, Stellar, US, Codra, then Clarion, Tron, and Hydra. So Ethereum, Stellar, US, and Tron, these are the public blockchain. Hyperledger, IBM, and OpenChain, these are the private blockchain. IBM blockchain, as I've already given the example, and IBM blockchain, Hyperledger, they are the private blockchain. IBM blockchain is particularly used for the IBM company, that nobody else can use this. Consortium blockchain, it is called as Codra. Codra is nothing but it is the decentralized concept. Codra is very limited. That means, like in Ethereum, what I told that using GANS we can implement 100 number of blockchains. For Hyperledger, we can having 16 number of nodes, right? And a hybrid blockchain, Clarion and Hydra. So these are the two platforms well known for the hybrid blockchain. So definitely, if you want to work on the blockchain, public and private, these two are good options to work with. Because Consortium and hybrid blockchain, they will be very hard to work with them. Okay. So next is one more concept present in this blockchain concept is the double spending attack. What is double spending attack? Double spending attack means what? Suppose the user. This is the user means this is the hacker actually. This is not the normal user. This is the hacker, right? It has only one BTC in its account. So what it will do? It has two merchants. Suppose you can merchant A is Flipkart, merchant B is your Amazon, right? And for this, it has been implemented in a blockchain platform. So sending money with the same ID. That means suppose I have the user has one BTC in its account. So what it will do simultaneously, it will do the two transactions. One BTC he will be transferring to the merchant A, and one BTC he will be transferring to the merchant B. Right? What happens with the same ID? That means from the same wallet, only one ID or one BTC is there in my account. The same BTC, it is not going to be transferred until the certificate authority here sending here invalid. Here the CA is working actually. If the CA is not validating, it is not going to transfer to the merchant A and merchant B, right? So if it is transferring the data from one BTC to merchant A, one BTC to merchant B, but the hacker is having only one BTC. Here he is trying to send two BTC, but it is having the one BTC, right? Verification process will take some time, right? In meanwhile, merchant A will be sending the data. Okay, you have initiated the money, so I will be sending you the goods, right? Merchant B will sending you the goods. But in the same time, what the CA is finding, okay, now he is doing the same ID, two transactions, but the BTC is only one. So what they will be doing is they will be making these two transactions as invalid, right? Invalid. First transaction invalid, second transaction invalid. So what happens in this case? Merchant A is not getting the money, merchant B else is not getting the money, right? But the user, the hacker is getting the goods from the merchant A, and hacker is also getting the goods from the merchant B. So this is what called as your double spending attack, right? To avoid this double spending attack, we have one popular solution to apply the consensus mechanism in the blockchain. What is consensus mechanism? Consensus mechanism means each and every node, the node cannot transact until and when the each and every node present in the network are not agreed on a common decision. So this is what called as your consensus mechanism. For example, the POW, proof of work, I have already explained whenever I was discussing about the working of blockchain. So there I have already explained that how the proof of work being executed. The proof of work is executed to reach a common decision. Okay, he will be the CA because he has submitted the proofs for the first time. He has solved the problem for the first time, right? So that's why consensus mechanism is nowadays used to avoid the double spending attack. What is the double spending attack? Penny attack, 51% attack. So these are the few double spending attacks we are having in the blockchain network. Next, talking about the consensus mechanism. Few, not this, around 20 to 25 consensus mechanism are there. Proof of work, I have explained. Proof of stake. Proof of stake means what? The person who is having highest stake means money, right? Highest stake in his wallet, he will be become the certificate authority. But again, one certificate authority is for the one transaction that is been modified in the delegated proof of transaction or delegated proof of stake, proof of consensus mechanism. In this what? Not selecting one. In delegating, they will be selecting 21 groups who are having highest to lowest amount in the BTC, right? In the wallet. That means suppose one node is having 100 BTC, another one is 90 BTC, another one is 80 BTC. Likewise, 21 nodes will be selected and they will kept in a pool. Right? So every time the transaction will be initiated, not searching from the entire node, rather they will search in the delegated proof of stake. By using this, what happens? The sort space definitely decreases, right? Suppose 100 number of nodes are there. Now my restriction is there, not in the 100 space. I need to search in the 21 space. So definitely the time space or time consumption will be very less as compared to the previous one. Proof of work, the high time consuming, high net money resource utilization. Proof of stake, also you are trying to search a single CF from the 100 number of nodes. But the delegated proof of stake says that, okay, not in the 100, we have the 21 buffer time. From the 21 buffer memory, I need to select one CF for my transaction. So delegated proof of stake is nothing but the enhancement of proof of stake where the user trying to reduce the space where the CA can be searched. Proof of capacity, proof of capacity means the resource, the node which is having highest amount of resource will be called as proof of, will be having the CA. Next is proof of authority. Proof of authority means what? Trust. For each and every transaction, the node will be the trust factor for the node will be calculated. The trust depends on various things like how many number of transactions it has done, how many positive transactions they have done, how many negative transactions they have done, how is the experience, feedback from the user. Coagulating all those things, the trust will be calculated. Next is proof of activity. Proof of activity is it will be counted. It is a counter value based on a counter value. Number of successful transactions versus number of malicious transactions. Those per node will be having the highest number of successful transactions will be always having the highest priority for becoming the CA. Okay. Proof of elapsed time. Proof of elapsed time, it is very rarely used. Elapsed time means what? Okay, first I will be explaining the Byzantine fault tolerance, then we'll be going for the elapsed time. Byzantine fault tolerance means suppose n number of systems are there. Okay, n out of n number of systems, suppose what happens, 50 systems are hacked, then I can manage myself, right? But if the 51 system has been hacked, my system is down. So I need to ensure that Byzantine fault tolerance means how many number of systems, if damaged, I can tolerate with that, right? Suppose I can have the threshold value is 50. That means if the 50 number of transactions will be deleted, or 50 number of computers nodes are malicious, then what happens? My network will be running smoothly. But if the 51st number of systems is gone wrong, then my network is down. Okay, so these are the few things like Byzantine fault tolerance was there in order to deal with the Byzantine general problem. Initially, it was developed by when the Byzantine problem was to solve. Like the problem we are facing in the Byzantine general problem. For that, we are having the Byzantine fault tolerance problem. How many number of How many number of systems, if they are going malicious, then we can have the transactions ongoing or successful transaction as much as possible. Okay, then talking about the proof of elapsed time. Proof of elapsed time is ensures that I can say that random selections of CA, right? It is quite similar to the proof of work, but it is very platform specific. It is hyperledger sawtooth. Sawtooth. It is a blockchain platform. For that blockchain platform, proof of elapsed time has been developed for that, right? So in that, what happens? The random node will be selected for a random number of time. That means, suppose I will be giving a value. Okay, this node can become a 5 number of times CA. Right, this node can become 5 number C. That means 5 times it becomes a CA for the transaction. After that, it has to re-register from the network. Again, it has to register itself. Okay, this is what called as proof of elapsed time. Elapsed time means I need to put a restriction on which, okay, this condition can also be implemented in this theory. That means putting a number of restrictions, how many times the node can become a CA. That is also possible for Ethereum as well. But it is the proof of elapsed time is basically developed for the hyperledger sorting. It is not, proof of elapsed time cannot be directly implemented in the your Ethereum blockchain platform, but rather the concept can be used. In the use case 2, we will show that the concept can be used. Okay, so these are the tools in which we can execute the platform. That means for writing the smart contract with the Remix and Atom. Solidity compiler, that means if you are talking about the Ethereum blockchain platform, then the general language we are following is the Solidity language, .sol, right? So Solidity language, they will be implementing by using the Solidity language. For that, we are having the Remix and Atom. These are the two browsers or two platforms we are having for the okay. In the Notepad also, you can use the language, Solidity programming language, but it will not supported by the Ethereum package, because in Atom it is supported by the Ethereum because it has the capacity of language Ethereum package. So your Solidity language or your smart contract will be recognized by the Ethereum blockchain platform. Next one is Solidity compiler. For Solidity compiler, we are having two things. Remix can be used for some executing the smart contract, and Trufflesuit, it also be can use for validating or for executing the smart contract. And for blockchain, we are using Rockstone Testnet, Ganes. These are the samples of two platforms or two GUIs, graphical user interface, where you can visualize, okay, these are the number of nodes, what is the data coming, the given experience. Just, we have given like the snapshot where we are showing the transaction. That is the snapshot of Ganes, right? Now, suppose you want to visualize the blockchain, because blockchain cannot be visualized directly. You have to go for a simulation tool. What is the simulation tool? Ethereum Remix, Ganes, Blockchain Demo, SimBlock, Hyperledger Explorer, and IBM Blockchain Platform Visual Tool. These are the few blockchain tools available in which you can visualize the blockchain concept. Otherwise, it is not possible to visualize, because if you directly upload the data in a Ganes, that is called as Go Ethereum, right? Get it for initializing, it will record around 1 to 2 hours for initializing the network and to raise 100 number of nodes in a get. So, but we cannot see what the data they are sending, what the data they are receiving, what is the block structure, what is the time span, what is the hashing mechanism, where to find the Merkle root to, that is not visible in the care. For that, we have to coagulate our Go Ethereum with the Ganes platform or SimBlock or Hyperledger. Any of them you can. Ganes is a very good option if you want to execute in the Ethereum blockchain. Just implement it in the Git, see it in the Ganes. Okay. Now we are having the main important part, that is security via blockchain. Security via blockchain, this figure shows the basic internet-based communication. That means where we are dealing with the internet-based. Right now, all of us, we are dealing with the internet communication, right? So how the internet-based communication are being executed? Three things will be there. One is sender, one is RA. RA stands for Registration Authority, CA stands for Certificate Authority, and VA stands for Validation Authority. Right? Three persons will be there who are holding the entire responsibility for signing the authority, for validating the authority, and for request granting authority. Right? Okay. So suppose you have some data to send, then what happens? You have to forward that I have the data to send to the registration authority, right? Then the registration authority, what it will do, it will forward your request to the certificate authority. Then the certificate authority will generate a certificate private key, and it will forward to the user, and the same public key will be forwarded to the validating authority for validating the transaction, right? Once the sender is receiving the key from the certificate authority, what it will do, it will embed the digital signature receipt from the CA with the data, and it will be forwarded to the receiver. Once the receiver receives this data, what happens, as I have already explained, this data needs to be verified. The signature needs to be matched. The signature are matching or not, right? If they are matching, the data can be decrypted. So what it will do, it will forward the request to the validating authority who will be verifying the signature of the CA. Public key has been provided by the CA. Now it will unlock the or decrypt the signature. It will see, okay, signature is matching. Then it will send the, okay, signature verified. Then the receiver will be receiving the data. Okay, so now what happens in this scenario, entire situation depends on these three parts. One is register certificate authority, one is validating authority, one is your registering authority. If we will zoom in, the entire process is depending on the certificate authority. If the certificate authority is giving the malicious certificate, then the entire communication becomes the malicious. What are the communication? What are the well-known certificate providers? One is Komodo, Identus, Digisort, Saturn, Enpro, Satigo, Global Sign. These are the available certificate authority certificate providers for our internet-based communication. In 2011, Digitus has been attacked by the hacker. Okay, it has produced around 675 number of wrong certificate, malicious certificate, so that it has been blocked. In 2011 December, again your Komodo has given 67 number of malicious certificate. So to avoid this scenario, now we are having the blockchain into the picture. Okay. What are the previous limitations present in the previous case? In the previous case, what are the limitations we are having? One message is where the centralized single point failure. That means this means CA goes wrong. That means entire communication will be wrong. Okay, if this CA will be goes wrong, then the entire communication becomes malicious. So this is called a centralized point or single point failure. Next is centralized authority concept. Next is no mechanism has been developed to recognize the malicious CA. So that is the reason why in 2011, 6 to 7 attacks has been done in the on the certificate providers. They are providing the malicious certificates. Okay. Then talking about the solution. Initially, we are having two solutions. One is web of trust approach, another one is log-based approach. Okay, web of trust approach means I don't believe on you. I don't do believe my trusted party. So what I will do, I do elect only that person I do believe, right? So I will select the person who I believe as a CEO. Next is log-based approach. Log-based approach means every activity of a node will be maintained in a public log. Like if the public log will be verified, okay, which is malicious, which is not malicious. Suppose a node A is doing the malicious. Now what I'll do, I will just write okay, malicious A, so node A malicious, node B suspicious, node 3 that is good. That means they are not. It is an active node. They are not present, not giving any kind of malicious activity, not showing any suspicious activity. But condition is in web of trust. Suppose a new network joins, right? If some new network joins, a new node joins to the network, what happens? Nobody will believe on that. So obviously, the older version networks will be definitely responsible for making the valid or validating the transaction. So new joinee will never get a chance because no network or no node will believe on the same node that okay, I can believe you validate my transaction because it is the new to the network. Next is centralized. This public log is becoming a centralized point. If I will be changing the values in the public log, the CO becomes malicious. From malicious to it becomes the active node. So to avoid entire these things, we are having one solution that is called as your blockchain-based public key infrastructure. This is the primary focus where we are dealing with the security aspects. Okay, so we'll be giving some use case descriptions for the security blockchain-based PKI as well. Okay. Sir, how much time we are having for this? Hello? 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 Hello.
Yes, you are audible, sir.
Sir, how much time we are having for this?
What, sir?
Oh, how much time we are having now?
You can continue, sir.
Okay, okay, no issue.
15 or 20 minutes.
Okay, sir. Okay, then thank you, sir. Thank you. Okay, so the first use case that is we have developed one DF for the healthcare. So that use case is to develop a healthcare, so DF for a healthcare domain where the doctor and patients are having platform where they can exchange their information with each other without involving the third party. That means without involving the agents from the picture. So the purpose of this framework is to integrate the blockchain platform for the EHR first and then to enable the secure electronic record storage for the user. That means we are going to give you a platform where the patient can directly connect the data, directly store the data, as well as where it is storing, I need to store the data in a blockchain. That means once the data has been stored in a blockchain, in terms of DLT, we cannot change the data. We cannot change the data because it is immutable in nature. So we cannot change the data. So option storage is there. Option storage means the user can store the data at their own end. On-chain storage is also there with the DLT, part of DLT or the copy of DLT will be stored in the blockchain network. So no way you can alter the data. Okay. So this is the use case diagram where the user is the patient, another one is doctor. The patient can register, patient can upload the health record, patient can connect to the doctor by uploading the EHR. I will be showing in a snapshot where the user will enter the data and the data will be visible to the doctor. So doctor has to register itself. Doctor can access the EHR and doctor can see the patient list. That means suppose I am interested in this patient. So definitely what happens, I can see the patient list. This patient list will be stored in a on-chain state manner, in a blockchain. In our blockchain, the on-chain storage is there to store the patient list, to store the EHR, electronic health record. Suppose I need to upload my diabetic report. Suppose I need to upload my EHR, ECG report. So I can upload directly. And suppose my physical copy goes damaged, then my soft copy will be there always in the blockchain. Right, so from the doctor can access the EHR by by seeing the EHR they can predict okay what kind of disease the patient is suffering from, accordingly the what kind of prescription we need to go for that, right? And remember we are deploying entire this system in Ethereum blockchain, and for this we are having the your payment portal as a MetaMask. MetaMask is a platform where the patient or register can register their self, the patient will pay and the doctor will be receiving the money in terms of ETS. Okay. So this is the block diagram where the user can interact with the doctor. Okay. So first of all, the user has to register itself. Once the user becoming a network, or sorry, user becoming a participant of the network, what happens? It has a one key, right? It has two keys. One is private key, another one is public key, as well as the ID. So whenever he or she needs to register in the Go Ethereum portal, so what happens? She has to provide his name, age, public key, and registering as. Registering as means there will be two options for that. Whether you are registering yourself as a patient or you are registering yourself as a doctor. So this is for the registration portal. Once the doctor or the patient has uploaded the patient and selected, suppose doctor A, B, C are there, right? If once the doctor A, B, C, D, E, F, G, anything, any number of doctors can register themselves in our portal. So now once the patient has successfully logged into a system, it has an option. Okay, now you can upload your document, few medical records, right? So here we can access the, or we can store, we can upload the EHRs to our portal, which EHR will be stored in the database. For the database, we are using generally for the blockchain, we are using IPFS server for storing the interplanetary file system server for storing the documents received from the user and the doctor. Okay, so this is off-chain manner because we cannot afford large amount of memory in a blockchain. So that's how we have implemented in off-chain manner. so that this IPFS will be used to store the data that has been uploaded by the patient, and same will be retrieved by the doctor. Okay, so now the second information, the doctor will be, doctor's records will be visible to the what, to the patient. That means here Dr. Rahul and Dr. KK, right? These two doctors are available. These two doctors can access my EHR. Suppose I have shared, the patient has shared the EHR or electronic health record. Now the patient is selected. Okay, Dr. KK and Dr. Rahul, these two have the are the most renowned doctor in the hospital. So I will be doing is, for cardio I will be consulting Dr. Rahul, and for diabetic I will consult Dr. KK. So what I will do, I will give the access to the EHR to the both of them doctor. Now meanwhile I thought that Dr. KK is not good enough. Right, Dr. KK is not good enough for the diabetes. So what I will do, I have the patient has the capacity to revoke the access from the doctor. Doctor cannot directly go do anything. The once the registered patient has selected him, they can only, then only the doctor can access the EHR of the patient. Right. So now Dr. KK, I have selected the Dr. KK. Now Dr. KK has given some medical records, like some prepared some manuscript, prepared some prescriptions for us. Then we can view the records, like what diagnosis they have done. Now everything has been implemented. So what happens after successful verification, after successful consultation, the patient has to pay some money in terms of ETS. So here you can say we are having two doctors, Dr. 1 and Dr. 2. One is patient. Here the fourth one is patient. Right? You can select any of the, suppose you are the logged in as a patient, so you can select Doctor or Dr. 1 for paying the amount to the corresponding. These are the imported accounts. Imported account means these have been imported from the blockchain. So that's why imported account, imported account, imported account. Okay. Second use case is called as your smart contract. This is a blockchain based public key infrastructure where we have developed one public key infrastructure for a public blockchain, that is a Go Ethereum, by using Go Ethereum or Ethereum. This has been published in those two articles. What is the objective? The objective is to prepare a malicious PKI, private key, public key, public key infrastructure, so that the CA can be verified and also the CA can be checked for the malicious attack on, right? So these two facilities the PKI will be giving. You can select your own CA. Also there is a mechanism, you can select or you can see whether this CA is malicious or non-malicious, right? So I will go to the directly. I will be. These are the four different modules we are having for this public key infrastructure. One is participant, smart contract, signature, and revocation. So this is the overall workflow of our public key infrastructure, right? Where the user will be transacting anything. User has the data to transact, then it will check the status of the requesting node. Whenever I will be initiating, the first my network will check whether I am a new node. If it is an existing node, then directly it will go for the selection of the CA. Otherwise, I need to register myself for the network. Then I will having my own unique ID as well as private key and public key. If it is successful, then only I can transact the data. Right? For transaction, I need to be part of the network. Okay, so then initialize your signer node. This is the CA selection process, right? Initialize the signer node. This is the CA selection process. For the CA selection process, we have implemented DPoS, Delegated Proof of Stake consensus mechanism, where we are selecting 21 number of nodes for the CA. The objective was to minimize the sort space. That means whenever every time I need to select a CA, so every time instead of searching the CA from 100 nodes, I will be searching in a 21 number of node space. Okay. So now the signer node validation will be done. Once everything is done, then the signer node will be allowed to put the signature on the data. Okay. So here what I have told is proof of elapsed time. If you remember proof of elapsed time, I told that there is a restriction. I need to put a restriction that how many number of times the node can become the CA. Right, here also we have implemented the proof of elapsed time concept to put a restriction. Okay, you can become the CA for 5 number of, here we have given the threshold value as 5. Maximum number of node can become a CA, it is 5. After that, the node needs to re-register itself in the network. Right, so this is the workflow of the PKI. This is the right hand side, we can say that this is the block structure. Talking about the Merkle root tree, this tree is nothing but the Merkle root tree. Right, so this is actually we are executing in the Ethereum blockchain, so it is called as Merkle partition tree. Okay, this is not a Merkle root tree. Merkle root tree is for the Hyperledger, but whenever you are dealing with the Ethereum platform, so this is called as Merkle partition tree. Okay, so these are the different attacks we have just avoided, or we have prevented these attacks by using a PKI: DOS attack, DDoS attack, MITM attack, 51% attack, injection attack, routing attack, and Eclipse attack. These are the different attacks. These are the basic definition how we have implemented the prevented these attacks. Next is second is your the third use case is called as your CTV PKI. It is also another PKI. In this PKI, what happens? So we'll just will be explaining this model very smoothly. What happens initially? CTV PKI means this is a clustering based public key infrastructure. Initially, we are having 100 number of nodes, right? Initially, we are having 100 number of nodes. Do not do anything. Simply just initiate 500 number of transactions, because I need some data, so based on which I can make the clusters, right? So initiate transactions. From the transaction, get your input time, get your source address, destination address, validation time, etc. Everything you collect. Then apply two algorithms: K means clustering and your DB scan clustering. Because applying only one clustering also it can be solved, but we need to ensure that how many number of clusters we can form. Right? How many number of clusters we can form. So we have implemented two clustering algorithm only to ensure that okay, 2 or 3 or 4, how many number of clusters we have, that should be common in both cases. If it is 3, that the DB scan should give us 3 as a result. So based on the number of clusters, form the clusters. Then here we have applied the proof of authority. Here proof of authority consensus mechanism. Proof of authority is nothing but a trust based consensus mechanism. The trust will be calculated every time. Once the transaction is complete, the trust will be calculated again. Right, based on the trusted value or trust value, the node having highest trust will be giving the highest priority for becoming the CA. Okay, so the trust calculation will be executed every time the node wants to transact anything. If the node wants to initiate a transaction, then okay, go for the proof of authority, find a node CA, then complete your transaction, again go back for the trust calculation. How the trust will be calculated? This is the entire workflow of the proposed model. That means your CTV PKI. This is the trust calculation. Okay, trust will be calculated based on two values. One is experience value, another is reputation factor. Experience value will be experience will be given, both will be given the highest priority. That means W and W are the two weight, that means 0.5, 0.5 will be giving a same priority to the experience as well as reputation. Experience means it is from the user end. Reputation means how many number of times you have done the successful transaction, how many number of times you have done the unsuccessful number of transactions. Okay, so based on these two parameters, your trust will be calculated. Now, how the experience will be calculated? Experience will be calculated from the user end. That means positive feedback as well as the negative feedback. Okay, positive feedback, if you are giving the 100% result, if you are giving the successful transaction every time, then the positive experience will be given, or positive feedback will be given by the user. If you are going to malicious transaction, the negative experience will be given. Then reputation factor is the aggregation of intra-cluster as well as the inter-cluster trust. It is the trust. Okay, how many number of successful transaction you have done? Because you are becoming a CA means within the cluster you can become the CA, or outside the cluster also become. Here number of clusters we have now. one node can become a CA for the another cluster as well, right? So intra-cluster and inter-cluster, these two are the trust which is being calculated for the reputation factor calculation. Okay, based on the calculated rank, we are going to, based on the calculated your reputation factor, trust, and your this, we have to go for the rank calculation, because the rank is based on the trust, right? Rank is based on the trust, and based on the trust we can select one CA. So this is how we can calculate the RT is the response time, VT for the validation time, T stands for trust. Okay, RT, the RT by RT max, VT by VT max, T by T max, this is the normalization process. WR, WB, WT, these are the has been developed in such a way that this is not been constant, right? This, but WR plus WB plus WT is equals to 1. It is upon you which priority on based on which you are going to select. You may select trust, you may select verification time, you may request response time. Based on your value, your CA will be rank will be calculated. Then from the rank, the CA will be selected. These are the two clustering mechanism that has been implemented for making the cluster. One is your claim-ins clustering, another is DB-scan clustering. For applying these two clusters, we found that there will be two maximum number of clusters for this 100 number of nodes, right? K-means clustering, the cluster 0 will be having 72 number of nodes, and cluster 1 is having 28 number of nodes. DB-scan is 65 and 35. So from this we found that okay, two number of clusters can be formed. It is confirmed K means giving K value is 2, DB-scan is also giving K value. How these things have been defined to the day it has been determined by the internal validation method, that is elbow method. From elbow method we have defined the K value. From the K value we have matched okay, how many clusters for the DB-scan, how many clusters for the K means clustering. Right, for the DB-scan we have calculated the CLOT score, and for the case means we have calculated we have used the elbow method. Okay, now this formula, remember this formula where we have calculated the rank. Rank is based on three things. One is the response time, validation time, and T. As I've already told you, these three values you have to give, right? The response time you have to give, validation time you have to give, and trust also you have to give. So the budget will be defined by the user. 110, that means user 1 means your response time will be 1, WR is equals to 1, WV is equals to 1, and W this, I don't require the trust, right? So you can give the 0, that means the will be calculated as WR plus WV, this terms becomes 0. If you don't require the trust, give it as a 0, because these values will be 0 or 1. Okay, 0 or 1. Or if you give that okay fine, I need to give equal weights, then I can 0.3, 0.3, 0.3. Okay, so T10, in the T10 transaction, the user requires verification time, validation time, as well as the trust. So the trust value near equals to 1 will be having as a highest trust value. Okay, this is the CLOT score analysis, K-means clustering, and this is the your number of plots. That means how many number of plots. This is the K-means clustering, and this is the DB-scan. Okay, so here number of clusters we found in the both cases is as your 2. So that's why we have executed the entire PKI for the cluster 2. Every time, remember, every time you want, after some we have given the 100 number of transactions we have given, after every 100 transaction the clustering algorithm again applied, because maybe some node has been deactivated, some node has been re-registered themselves from the network. So every 100 transactions we have written the smart contract like this, that every smart 100 number of transactions your K-means clustering will be implemented, and number of clusters you have based on the K-means cluster and DB-scan clustering, they will be formed, and finally the PKI will be done. So these are the three different use cases. First case is this use case can be found in IEEE Access as well as IEEE Conference. And second use case where we have this can be found is your emerging transaction and telecommunication technology. Then use your Springer conference. And first is it is a Web of Science journal, that is your IGI Global. So on all those three code are available on my GitHub link. So you can search in in a GitHub. There will be finding every code is there. These three codes are there in the block GitHub. CTV PKI and your first one is your first PKI is developed. We have developed for handling different kinds of attack, and the healthcare EHR. These three cases we have implemented, and we have given the code in the GitHub. So if you want to see it, then you can go for the GitHub and search my name. They will be find this how to implement these things. Now talking about the research upon your opportunity present in the blockchain. One is your layer 2 solutions, roll-up and channels. Roll-up and channels means you have to develop in a effective manner so that the time consumption for the validation and verification will be very less. Second one is sharding and DAG-based architecture. One TPS. TPS is a very crucial thing whenever you are executing anything in a blockchain platform, right? TPS means transaction per second. Ethereum, in Hyperledger, in Ethereum, it is very hard to maintain the TPS. If you will deploy one application in the thing, so definitely the challenge is to handle the TPS. Next is security privacy. Lots of mechanism or I can say that consensus mechanism are on the field. But right now, what we did that is zero knowledge proof. ZKP is in action to develop the PKI. That means ZKP based PKIs. In ZKP, you can implement ZK snacks and ZK stacks, right? And homomorphic encryption in the smart contract. Homomorphic encryption, in our application, we have implemented the classical cryptography mechanism, not in the homomorphic encryption. Homomorphic encryption means there is no need of decryption of the data. Okay, you can work with the encrypted data. You need not to do something, you need not to modify the data or decrypt the data. You can directly work with the encrypted data. Then green blockchain, that is also, and I am also blockchain, industry 4.0. Then interoperability, cross-chain bridges, then blockchain routers, messaging protocols. So these are the research area where the user can work with that. AI blockchain integration. AI blockchain integration, the better explanation will be given in the next slide. AI blockchain interest means suppose one blockchain, because the data set you will be getting very less, right? Proof of stake 101 data set, right? Proofs of ecliptic plus data set. These two are only data set present to measure how many numbers. That means these two basically aims to predict the malicious node, right? To develop a AI model that will detect the malicious node in a that will predict or detect a malicious node in a blockchain network. So this is one more thing, that is AI-based blockchain integration. You can implement the predictive learning. Then you can implement also the on-chain mechanisms, that means you can implement the machine learning, deep learning mechanisms, or your transfer learning techniques to verify the node on an on-chain manner. But this previous case, this case is called as your off-chain manner. Okay. Talking about the conclusion. So blockchain and technology nowadays is emerged as a transformative technology because it has converted the centralized into a decentralized concepts. Also, beyond from the key cryptocurrency, so it has various application domain: education, healthcare, finance, supply chain, and your whenever you work on this blockchain, the main objective is to measure the energy level, because energy level, measuring the energy consumption for a blockchain network is still in a challenging mode. Why? Because we are working on a free blockchain platform, right? If you are able to work on a paid version of blockchain platform like Hyperledger with the 50 number of nodes, Ethereum with the 200 number of nodes, then we can, there is option where we can measure the energy consumption. But deploying this things is very cost effective. That means you require some lakhs to maintain one node, right? Already I have explained that NFT. Okay, so NFT is a tag, right? NFT is a tag. To scan one NFT, I can guess, okay, who is the owner of this object. For that, NFT has been developed. Then the interdisciplinary nature of this blockchain. So it will be it is now collaborating with the computer science, economics, law, social science, everything where the blockchain is now merging. Okay, so blockchain is not just a part of technological environment; it is just a paradigm shift. You can continue the research from the blockchain 1.0, from the big Bitcoin to blockchain 4.0, unlocking the full potential for a decentralized and equitable digital future. That means whenever you want to execute a blockchain transaction, you want to develop an application for using the blockchain, always we have to remember the blockchain has been developed in for the security purpose only, for the decentralized concept, right? So whenever we are developing a blockchain based application, definitely we have to focus on these two cases, right? We can develop the DApp, but the security must be there. We can develop the DApp, but the decentralization should be there, right? We can develop the DApp, but the optimization should be. If you are doing this, then your DApp is good for the publication. That means publication means you can go for the application deployment somewhere else. Right now, we are also we are working some honey in back in Odisha, in Anupur district. We are working some honey management. That means we are implementing the SCM, blockchain based management system, or blockchain supply chain management system for honey and for the farmers, right? For the farmers, we are developing the supply chain management where the third party will be it will be not there in the picture. Directly from farmer to customer, transparency will be maintained. So the price will be reduced. These are the two projects we are currently working with: honey management and your farmer. These two applications we are currently developing. So these are the few blockchain based publication of mine. Other publications are there. I've only shown this. Few of them are. I am currently working on the blockchain based DApp and your PKI security and application. I am working with. Anybody is interested, they can he or she can connect with me. That we can collab. We can start working on this as well. Okay, now I'm looking any questions.
Thank you, sir. Thank you very much. So, anyone want to ask any question to sir? Thank you, sir.
Thank you, sir.
So, as we conclude this insightful exploration of next generation technologies, I would like to extend my sincere gratitude to our visionary speaker. Thank you for sharing your expertise and shedding the light on the latest advancement in blockchain AI. Your presentation has sparked valuable discussion and inspired a new ideas, sir. So, sir, we want to share a digital memento.
Okay, sir.
Is it visible, sir?
Yes, sir. Just a minute, sir.
Is it visible, sir?
Yes, sir. Visible, sir.
Okay. So your efforts are truly appreciated, sir. Thank you very much.
Thank you very much, sir. Thank you very much.
Okay, sir.
Can I leave, sir, now?
Okay, you can leave, sir. So
Thank
we
you,
are
sir. Thank you very much for the invitation, sir.
Okay, thank you, sir.
Thank
you. So thanks to our audience for your active participation. Okay, you can leave now.